So as I mentioned in the previous video, it would help if we could get even closer. So instead of being a half an hour away, 2.5 and 3.5, what if we were only a tenth of an hour away? All right, 2.9 and 3.1. This is that next section of notes that you have there. All right, so think about this for a second. Let's think in terms of an hour. All right, a tenth of an hour. How many minutes are in 1/10 of an hour? Well, how many minutes are in an hour? Yeah, 60. So a tenth of that would just be 6. So now instead of being 30 minutes away, we're only 6 minutes away from the 3-hour mark. Again, I'm just giving you more data, kind of adding it on piece by piece. So if we check and we see that 2 hours and 54 minutes, or 2.9 hours into our trip, we have traveled a total of 175 miles. Okay? And 3 hours and 6 minutes into our trip, 3.1 hours, we've traveled a total of 186 miles. Okay? So we're adding 2 more data points to the data which we already have. We already know that we have 180 miles traveled at the 3-hour mark. So now we're putting in the 2.9 at 175 and the 3.1 over 3.1 and up 186. Okay. Well, now again, we're just looking at the secant line for those 2 line segments right there. Those lines, we're looking at the slope of those lines. Those lines are almost on top of the pink. Okay, so this is a much better approximation than this line right here, which was way below our pink curve. Okay, we're getting more accurate with each attempt because we're getting closer and closer and closer to t = 3 with our data values. Well, what happens? We do a quick average rate of change here, average velocity. We see 180 minus 175, because again, we're using the data point that we know, that 3 comma 180, that's our key point. We use the 3 and the 180, we use in the 2.9 and the 175. We end up with 5 in our numerator and a tenth in our denominator. A tenth goes into 5 50 times. So for the previous 6 minutes to our actual point that we're interested in, we now know that we traveled an average of 50 miles per hour. And for the 6 minutes afterwards, if we do another average rate of change, another approximation right afterwards, right, that would be 186, 3.1, those are our bigger numbers, minus, or 186 minus 180, and 3.1 minus 3. So that's 6 over a tenth, or 60 miles per hour. So again, we're getting a closer and closer idea, because now we're not 30 minutes away, we're not 60 minutes away, we're only 6 minutes away. A lot less can happen in the previous 6 minutes or the next 6 minutes than the previous 60 minutes or the next 60 minutes rather. So we're getting closer and closer and closer. And in our final attempt down at the bottom of the page of those notes, now we're even going to go closer than that. We're going to go 100th of an hour away. All right, so you see that data point, you see 2.99 comma 179.9. Okay, so now we are practically right on that dot where we have our 3 over 3 and up 180. Okay, and then there's the other point, which is 3.01 and 180.1. Okay, well, if we look at this data, I'm just doing one of the 2. All right, you can try the other one as well, that's no problem. If we look at this data and we were to do an average rate of change, we would have 180 minus 179.9 over 3 minus 2.99. Okay, well, what is 100th of an hour? Think about how close that is. Okay, we already know that a tenth of an hour is 6 minutes, right? Because there's 60 minutes in 1 hour. If we divide that 60 by 100, we're getting a messy decimal. So let's go to seconds. How many seconds are in an hour, right? 60 minutes in 1 hour, 60 seconds in 1 minute. So we multiply 60 by 60, we get 3,600 seconds in 1 hour. We want 100th of that. 3,600 divided by 100 gives us 36. So now we're only 36 seconds away from the point that we're interested in. That's really close. There's not a lot that's going to be happening in all likelihood in the 36 seconds leading up to where we know to the point that we actually want. So this is our best data yet, because we're getting closer and closer to that 3-hour mark. All right, so if we do this out, we end up having, what? We have 0.1 in our numerator, and we end up having 0.01 in our denominator. Okay. Well, what happens when we do a tenth divided by 100th? Okay. Well, yeah, it's going to turn out to be 10 miles per hour. Okay, 100th goes into a tenth just 10 times. Okay. So now we can get a really good idea of exactly what's happening because we're only 36 seconds away. So maybe there was a traffic jam and we had to slow down. We didn't know that for the previous hour, but for the previous 36 seconds, it gives us a much better idea of what's happening with our instantaneous velocity, what's happening as we are approaching that 3-hour mark. And that's the idea in general with the instantaneous rate of change. We don't want to be far away and have a secant line which is not near a pink curve. We want to be really close right there. And if we're really close and we extend that line, we no longer have a secant line. What we have there is a line that just comes in and it touches the curve right at one instant and then it zooms off again. We have a term for that from geometry when you studied circles. We'll talk about that in a future video.